Okay. This is where we left off, and I left off by really struggling with this last bearings question. I've rubbed out all this junk, and now I'm trying to use. Oh, now I'm trying to use the cosine rule to find h. Now, let's just have a look at this. If I was trying to find h, actually, mic check. Good. Sorry. If we're trying to find h, then I kind of require either to use this triangle or to use this triangle. But I don't know anything about those two triangles. What I do know is, I guess I should put all the information that I do know on. I've found that that's 120. That was the last question. The question that I just did was giving me this AP. So this one down here. And that said that AP is H cot 39. And there's a reason that they've done that is because the question understands that it's impossible to find H without having these two. But what I can do is I can come up with expressions for this and this, which both have H in them. And therefore, this triangle down here, I can use the cosine rule on that because I know all three sides and an angle. That's what you need for the cosine rule. So using the same property, I can say that that's H cot 48. So purely by symmetry, like they're the same line essentially, just a different angle. And now I have all the ingredients I need. So what I'm going to do is over here, I'm going to redraw the triangle. Just draw it over here. This is that triangle on the base. That was 120. This was 1.2, and that's in kilometers, but I want my thing to be in meters. This was H cot, what was it, 48. And this is H cot 39. And now I have everything. So I'm going to call this C, C, A, B, and then I can use the cosine rule. So remember the cosine rule is C squared equals A squared plus B squared minus 2AB cos C. So I'll start filling it in. My C squared is 1.2. My A squared is H cot 48 squared. My B is H cot 39 squared minus 2 times those things. Cos C. My C is 120. Sorry for the vibration. Okay, so now I basically have a huge equation that has a bunch of h's in it, and I want to make that by itself, and that's going to help me. So it's kind of giving me a clue as to what to do. I couldn't really use the cosine rule on anything else other than this triangle. Okay, don't really know where to go from here, so I guess I'll just expand everything. H squared cot 48 squared plus H squared cot 39 squared minus, what have we got here? We've got 2H squared cot 48 cot 39 cos 120. So cos 120, 120 is here with the acute angle being 60 for all stations. So cos is negative here. So I'm going to end up with a negative 60. What's cos 60? That's a half. So a negative half. Okay. Or I could just type it into my calculator. I better check that because I'm definitely going to get that wrong. Cos 120, negative half. Okay. Oops. And that equals 1.2 squared. Let's, I guess we can factorize H squared out. So H squared, that side off what's left, cot squared 48 plus cot squared 39 minus 2 cot 48 cot 39. This sounds weird saying cot so much. Oh, actually, look at this. This is minus 2 times minus a half. So that's going to be plus 1. Bulb. Okay, let's just run that. Plus, move him. Equals 1.2 squared. Okay. If I just go, what can I do here? I'm going to divide it by all of this. So it's going to go into there. So H squared is 1.2 squared over, holy moly, this is a big motor working. No. Okay, so h squared equals that, which means h equals the square root of whatever that is. So I guess you could type that into the calculator. Oh, typing that into the calculator is going to be so annoying because it's cot. Okay, let's go another step. You can't type cot into the calculator. What I can type is 1 on 10. So I can write, oh my god, 1 on 10 squared 48 plus 1 on, this is a gross question. Who put this in? Plus 1 on, oh yeah, I can do that. 1 on 10, 48, 10, 39. Okay, and h equals the square root of that. Jesus. And when you eventually type all that in, you get around about 0.646. Now that's in kilometers. If you want to get to the nearest 10 meters, so that's equal to 646 meters. And in the nearest 10 meters, so 650 meters. Wow, you really earn your 3 marks there. Oh, look at that, I used every line. Okay. The acceleration, is everything working? Make sure everything's working. Seems to be, okay. The acceleration on a particle is this, okay. Initially means t equals 0. That's that to the right. And has this velocity, okay, they're my initial conditions. It's the second derivative, so I need 2 of them. Show that the displacement is given by that, okay. So they've given us the second derivative. I want the displacement, which is the original, so I'm gonna have to integrate this thing twice. Okay. So d2x on d, oh no, it's dt squared, e to the minus t plus e to the minus 2t. Now the first derivative, so dx dt, is the integral of that, which is going to be minus e to the minus t minus a half. So divide by the derivative of the top. Derivative of the top is -2. Minus e to the minus 2t plus c. Initial condition. So when time is 0, so initially, the particle is traveling at a velocity of this. So v, you could call this v. This is equal to v. V is equal to minus 3 on 2. Okay, so that means minus 3 on 2 is equal to minus e to the minus, so I'm just shoving 0 into here. Oops. Shoving 0 into here and setting it equal to t. Minus a half e to 0 plus c. Minus 3 on 2. Now that's minus 1. Anything spared of 0 is 1. Minus a half times 1 plus c. I don't like all these halves. Okay. What's minus 1 minus a half? This is minus 1.5. Minus 1 minus a half is also minus 1.5. That means c equals 0. Is that right? That equals 0. Oh, it does. Okay. So therefore, our first derivative is equal to minus e to the minus t minus 1 over 2 e to the minus 2t plus 0. So I just rewrote this line, but without this. There. Okay. Nowhere near done. How is this 2 marks? This should be way more. This should be way more than 2 marks. Yeah, it's not. It's meant to be 3. They changed it. Okay. Now I've got to integrate again. So x is equal to the integral of this. So it's just going to be e to the minus t. Divide by the derivative again. So that's going to make a plus 1 on 4 e to the minus t. Again, plus c. Adds, really? I want a Woody, thank you. Okay, I wonder if the music's too loud. when time is 0, our displacement, it said, was to the right, which means positive 3 over 4. So 3 over 4. So that means 3 over 4 equals e to the minus 0. It's 1 on 4, e to the 0 plus c. So that's 1 plus 1 on 4 plus c, 3 on 4. Okay, that's 0.7. I'm going to write this as decimals because they make more sense. What's 1 plus 1 over 4? 1.25 plus c. Okay. I can't do this in my head. 0.75 minus 1.25 is a half. Negative a half. Negative a half. C is negative a half. Now I have two C's. Let's call this C1. Let's call this C2. Okay, so therefore x is equal to e to the minus, that's a weird looking e to the minus t plus 1 on 4 e to the minus 2t minus a half. So all I did there was write this again, but instead of c, I wrote negative a half. And that should be done. Show that the displacement is that. Oh, they gave us the answer. Let's check it. Let's check it. Is that the same as that? Yes. I did not even realize that they gave us straight up the answer. That's really, really nice. Maybe that's why it's 2 marks. Yeah, right. Okay, well, done. Uh-oh. Another particle, P2, moves simultaneously. Oh, great. The acceleration is this. Okay, second derivative again. Again, it's to the right of that. And traveling at a velocity of that when t is... Oh, okay, so this is not when t is 0, it's t ln 3 seconds, whatever that is. Determine the exact time they're traveling at the same velocity. Okay. Alright, okay, challenge accepted. So I'm going to have to find the velocity of each of them and set them equal to each other. Hope that makes sense. So this one, let's find the first derivative. So d, oh, these should be named different things. Let's do this. P2, particle 2, dx dt. So I'm going to integrate this one up here. It's the same function, is it? No, it's that was a plus. This is a minus. So integrating this e to the negative t plus divide, so 1 on 2 e to the minus 2t, or plus c. Okay, and at time, now it's not 0 this time, it's ln 3, dx dt, which is v, is negative 3 on 2. Okay, so I need to replace this with this, and this with these. Okay. Negative 3 on 2 equals e to the minus ln 3 plus 1/2 e to the minus 2 ln 3. Okay, this is equal to, now I'm just going to bring this minus, these can cancel in a second, I just need this minus out of here. So I'm going to rewrite it as e to the ln 3 to the minus 1, so when you've got something on the outside of the log, it becomes a power, plus 1/2 e to the ln 3 to the power minus 2, so I'll move that minus 2 up. Okay, this is equal to, so now they can go, that's just 3 to the power of minus 1, which is the same as a third, plus 1/2, 3 to the minus 2 is the same as 1 on 3 squared, which is 9. Okay, this is 1/3 plus 1 on 18, negative 3 on 2. What happened to my constant? What am I even doing? There's a plus c on the end of all this. Okay, jeez. C equals, I'm just going to move everything and write it, 3 on 2 minus 1/3 minus 1 on 18, which equals minus 1 on 3 minus 1 on 18, negative 17 on 9. Let's see if that's right. 7, yeah it is. Sick. Should we call that number 3? Okay, so that means the first derivative is equal to e to the minus t plus 1/2 e to the minus 2t minus 17 on 9. So again, I just rewrote that as that. Instead of C3, I got my constant. What was the question asking? Oh yeah, the simultaneous one. So I need to show that when is this velocity the same as, where is it? This velocity. So I've got to set them equal to each other. So that was, whoops, particle 1. Particle 1 is dx on dt equals, geez, what is it? Okay, minus e minus t. I'm going to forget this so quickly. Minus e minus t minus 1/2 e minus 2t. Minus 1/2 e minus 2t. Okay, let me just make sure this is correct before I start trying to simplify this. Yeah, okay. Now, if I want to know when they're the same velocity, I set them equal to each other because they're the same thing. So I'm going to go P1 equals P2, which is minus e to the minus t plus 1/2 e to the minus 2t minus 17 on 9 equals minus e to the minus t minus 1/2 e to the minus 2t. Okay, let's get to simplifying. He's going over here and making a plus, which will make 2 of them. So 2e to the minus t. Then I'm going to move this, I'm going to move this guy over here. So that's going to make a plus, and that'll make a whole one. So that's plus e to the minus 2t. Why did that? T minus 17 on 9 equals a 0. Now what? Yeah, right. Now what? How do I get e? How do I get? What am I even trying to do? Determine the exact time. T. I need to get t by itself. How is that going to be possible? Okay, well I'm thinking this is like a squared. That's like nothing, and that's kind of like a constant. So, and it's equal to 0. I'm thinking quadratic. So let me rearrange this as e to the minus 2t. I'm just swapping the 2 above. And I'm going to rewrite them as e to the minus t squared. So I took the 2 out, plus 2 e to the minus t, minus 17 on 9 equals 0. Okay, let's make this make more sense. Let e to the minus t equal u. Then I've got u squared plus 2u minus 17 on 9 equals 0. Okay, now I can actually factorize this. Well, use quadratic formula. U is equal to minus b plus or minus the square root of b squared minus 4 times a times c, all on 2a. Okay. Into my calculator. Minus 2 plus the square root of 4 minus 4 outside of minus 17 on 9 on 2. What did that give me? What the hell? This calculator fully simplifies a surd. Happy with that. Okay, roundabout. Do these need to be exact? Do not simplify your answer. Okay, well, calculator did it for me, so minus 3 plus or minus, wait, what? How did this end up as minus 3? God knows. Root 26 on 3. Yeah, right. Is that what the calculator got? Oh, okay. That's fine. Okay, I'm going to leave it like this. The reason there's 3's instead of these 2's is because what you can do is, in this case, the 17 on 9, just times everything by 9, so then there's nice numbers. that would give that. My calculator simplifies that, so that was cool. Obviously that's illegal, but whatever. Let's draw a line here. Now that was u. So that means, what does that mean? If u equals that means e to the minus t equals that. So e to the minus t equals minus 3 plus or minus root 26 on 3. Still need to get t by itself, so I'll take the log of both sides. That'll bring the minus t down. Log of minus 3 plus, this question's effed. And then t equals minus 1 minus 3 plus or minus root 26 on 3. Holy moly. How many marks is that? 4. Yeah, okay. See why. Don't simplify your answer. Wow, that's really nice. Okay. See, these questions are so common. 21 minutes already? How many questions are there? Uh-oh. I'm in danger. Okay. New investment fund, 6% per annum, quarterly compounding. Let's just deal with that first. Divided by 4 is 6 divided by 4. 0.015. Okay, that's my rate. He makes deposits of $4,000, so that means he puts it in, so it's plus $4,000. First deposit is made immediately after the account was open. Okay. Quarter years, so A of N and N is what we're using. If he maintains it for 9 full years, okay, so quarterly for 9 years. 9 years quarterly, that's 36 time periods. Holy moly. His fund, oh, it's given us the answer. He's saying show that this is the answer. Well, at least we know where we're going. Alright. That's basically telling me that A30, so that's saying that A36 is equal to that. That's what it's kind of telling me. Okay, I like it. Make sure I'm good. Alright, so if the first deposit was made immediately after the account was opened, that means no money is compounded. So, and a month hasn't passed yet. So at time 0, he puts $4,000 in. Then at time 1, I'm gonna need this whole page, I reckon. Then at time 1, he's got his $4,000. It compounds. So 1.015, so that was this, goes up by the rate, goes up by 1, then he deposits $4,000. Okay. Do I want to keep going? Do I want to factorize that? Let's factorize the 4,000 out. 1.0151 plus 1. Okay, then the second year, he's got A1, so what he ended up with, that compounds, and then he adds 4,000. Okay, I'm going to need some space for this. So A2 equals, so A1 was, let's use huge brackets, 1.0151 plus 1. Yeah. And then it compounds, 1.015. And then he adds $4,000, okay. So I put in here this, so that's there now. And then the rest of it's here. Okay, let's expand. So this is the same as every question. So this is going to go into here and then into there. So 4,000 bracket 1.0152 plus 1.015 plus 4,000. Now, oh, there's a bracket there. So now I'll factorize 4,000 out. So 4,000, 1.0152 plus 1.015 plus 1. So that's 1, 2, 3, 1, 2, 3. Okay. Jesus. Now, you just do this till you get the pattern. I think I already get the pattern. This one's quite simple. It's 2, and then there's 2 of them, and then they just go down. That's it. So now what I can do is I can take the sum of this thing. So I'm trying to find A36. I've only got A2. I don't have to do this 36 times. I would not recommend that to the meanest of people. I've actually saved myself some working by factorizing this 4,000 out, so that's kind of nice. A is equal to 1. R is equal to 1.015. So the sum is going to be the sum of... Now think about this. If I'm trying to find A36... Oh, actually I haven't finished. Dot, dot, dot. A36 would look like this. Now you can see, so maybe I'll do this in a different color. This part in here, A equals 1, so the starting term, I'm doing it backwards. R is 1.015. Now there's actually 37 terms because this goes from to the power of 0 to the power of 36. So if you count backwards, it's 37 instead of, so S of 37 is what we're trying to find. So maybe I'll just leave the 4,000 out here. So it's 1 outside of 1.015 to the power of n minus 1 all over 1.015. So this is just the sum of an infinite series equation. Okay, and that should give me A36. And I bet you it equals what I'm trying to find. 4,000 sort of 1.015 to the power of 37 minus 1 bracket 1.015 minus 1. My calculator gives me 195,940.435. Would that say? Holy moly, that looks extremely similar to what I wanted. Yay. Gotta love a show, that question. Okay, 3 marks for that. What is the single sum required when invested under the same conditions that would reach this value after 9 years? Okay, so I don't like how this question is worded, but single sum kind of implies what's the amount you'd need to start with if you didn't do anything. So by not doing anything, you're not depositing anything. So in other words, just regular compound interest. The only reason we do this whole thing where we go through all of them is because we're depositing something. But if we're not doing that, if we've just got a single sum means rather than dumping $4,000 every month, I just put one amount of money in and let it compound. So in other words, I dump one thing in, my present value, that's what I dump in. I want that to compound over 9 years, so 36 months. And I'm saying that I want it to reach what it reached before, which was 195, what was it? 940.44. Okay, so what amount do I have to dump in rather than me spending all this time every month putting $4,000 in? So that's kind of what I'm starting with. Is that right? Yeah. Now I'm just going to solve this. So this is pretty easy. This should just be 1 mark, yeah. So PV equals, and I'm literally just going to get this and put it underneath there. So 195,940.44 on 1.015 to the power 36, and that's around about equal to 114,642. So if I put that in the calculator, so wow, that's a lot of money, like $100,000. Just after 36 months, so 9 years, it only compounds. Actually, that's quite a lot. What's that compounding? Like 70 grand or something. Okay, how many full months will Alex's fund reach $500,000? Now, that's kind of saying after how many full months, so n, I don't know, will it reach this? So the total, A of n, reaching 500,000. So this is the point where you just look back in your question and say, do I have an expression for an? And, well, I kind of do. It's this, right? I just change n to that, n to this, but I don't have to perform this sum again. So really, I kind of just use this and replace 37 with n. So that's what I'm going to do. Let's actually just copy that, eh? Copy. And don't do this. What's happening? Paste, please. Oh my god, I pasted 3 dots. Extremely triggering. Now I look like a boomer. Stop. Copy. Should have just written it. Would have been quicker. There we go. Okay. So A n equals that. But I know what a n is. It's $500,000. Okay, so now I just got to solve this thing for, instead of 37 months, it's n months. I have to solve for that. Gee, that looks fun. Okay, 500 grand times, now this is 0.05, 0.015, because actually I'll divide by 4,000 at the same time. Divide by 4,000. It's going to equal 1.015 and minus 1. What's that thing on the left? Times 0.015 on 4,000. 15 on 8. Ooh, getting nice numbers here. 1.5 and minus 1. Let's add one. That's 23 on 8. Let's take the log of both sides. Let's move the n out the front. Let's divide by it. And that's around about equal to ln 23 on 8 ln 1.015. I get 70.93. Okay, what does that tell me? What was the question? How many full months? Okay, so I need 71 months to get there. Is that the answer? Surely. It is. Oh, it is. No, it's not. Why isn't it? Solving for n. Oh, trick question. What a stitcher. That's how many quarters. Yeah, right. What a stitch-up question. Because these were compounding quarterly, n is in quarters. So really I need to go 71 times, how many months are in a quarter? 3. So that's 210, 209. 71 times 3. 213. So 213 months. Oh, that's a doozy. That should be worth way more than 2 marks. That's a stitch-up question. Well, now these 3 dots are triggering. Okay. A soft drink company produces a bottled drink. The amount of liquid poured into each bottle by the bottling machine is normally distributed. Oh, that means bell-shaped curve. Mean of 300. Standard deviation of 10. Okay, 1, 2, 3. 1, 2, 3. 290, 280, 270. What percentage of bottles would have been between 310 and 330? So 310 and 330 is here. Oh, these questions suck. Okay. Let's use a zillion colors. This whole thing here is it 99.7? I think. Reference sheet. Help me reference sheet. No, it is 99.7. Okay, so that's 99.7. I want to take away this part. So take away the 68%. Okay, so that's gone. What else do I want to take away? Then I want to take away this part here. So that's minus half of damn it, that's not half, is it? This is gonna be so confusing. So this whole part here is 90. Damn it, what is it? 90. Is it 95? I think it's 95. 95. So 95 minus 68, and then halve it. So 95 minus 68. Okay. And then let's use purple. This part is going to be half of. This whole thing is 99.7 minus this 95. So 99.7 minus 95. Wow. Okay, that should give me the blue part. So the blue part equals 68. I'm sure there's an easier way of doing that. It has to be. I got 15.85%. Does that seem right? I don't know if that seems right. Oh, it is right. Okay. A bottle has a z-score negative 1.2. Okay, let's just write the z-score formula. It's... Oh, damn it! Reference sheet. X minus mu on standard deviation. Okay. So 1.2 equals... So my score is... How many mil under the mean is this bottle? That's a good question. Let's find out what the actual score is. X minus the mean, which was what? 300. Standard deviation was 10. So that means 12 equals X minus 300. That means X equals, what's 12 plus 300? 312. How many mil under the mean? How many mil under the mean? Under. That looks above to me. Am I an idiot? That was a minus. That was a minus. So X is going to be 288. So therefore 12 mil under. Transcription error. I wouldn't have lost marks there because I just rewrote the question incorrectly, but none of my working was incorrect. The only reason I found my mistake is because it made no sense. In order to comply with local regulations, no more than 2.5% of the bottles may contain less than the amount of liquid indicated on the bottle. I think that's a real thing. What is the largest amount of milliliters the bottle's label should show in order to comply with regulations? Okay. Okay, so let me just draw my bell curve again. I don't know why this is 3 marks yet. No more than 2.5% bottles may contain less than the amount of liquid indicated. Okay, so what is that saying? 2.5. 2.5. It's the largest amount. I don't really know why that's 3 marks. I'd love to know where the marks go. Oh, it has to have been changed. There's no way that's a 3 mark question. That's actually just 2.5 is the little so like this 95, which is 2 standard deviations. So z equals minus 2, z equals 2. So 2 standard deviations, that's x is equal to 300 minus 20, which is 280, and then x equals 320. So what's the largest amount of milliliters the bottle's label should show in order to comply? The largest amount of milliliters. Is that saying this? Or is it saying this? Wow, this has confused the hell out of me now. Wouldn't it have to show, what's the largest amount it should show in order to comply? Well, if it's indicated that it's got 300, then it can't be 2 z-scores less than that. Less than the amount of indicated on the label. I don't like how that question's worded. The answer is 280. I'll come back to that. I don't like that. Okay. A 100 centimeter length of wire is cut into 2 pieces at point X as shown in the diagram. The piece that is length X is used to form a circle, and the other is used to form a square. Show that the total area of a circle and square can be given by that. What the hell? Okay. Let's go with the square first. So the area of the square is going to be equal to show the area of the circle and square can be given by a piece that is length X. Ooh. Is cut into 2 pieces at point X. Okay, so that means the piece that is length X is used to, okay, so this is length X. And this is length 100 minus X. Okay. Oh, okay, I was getting heaps confused then. Right, okay. So this is used to form a circle, and this is used to form a square. Okay, so a square is going to be 100 minus X. Hang on. Okay, the perimeter is going to be 100 minus X divided by 4. Do I care about that? That's the perimeter of the square. So what's the area of the square? Actually, how is the perimeter that? That doesn't make any sense. One of the sides is that. So side 1 is going to be side 1 squared, which is 100 minus X squared on 16. So that's the length of one of the sides. And then to find the area, I just do side times side. So that's that. Oh, that's actually this. Okay, so that's the area of the square. That's confusing. For me, area of the circle. Okay, so a length X. So that's going to be the circumference, 2 pi r, is X. That means the radius is X on 2 pi. Okay, so that's actually the circumference. The area of the circle is pi r squared, which is pi x on 2 pi squared, which is pi times x squared on 4 pi, which is x squared on 4. Why is there a pi still there? Oh, that becomes squared. And then that go. Okay, so then area equals x squared on 4 pi plus 100 minus x squared on 16. 3 marks, that's pretty generous, but that involved a lot of thinking. I had to think about that for a little bit. Mic check on. At what length should x be cut to minimize the total area? Okay, well that tells me I need to integrate. So what was the area? It was, that's why they've given me the answer. X squared on 4 pi plus 100 minus x, was it all squared? Yeah. On 16. Now the derivative of the area with respect to x is equal to, okay, I need to rewrite it. I hate how it's written. Okay, that's going to be 1 on 4 pi x squared plus, do I want to expand that? I guess I do. 100 squared. Oh, it's all divided by 16 as well. 1 on 16. 100 squared minus... I don't need to do that. Don't worry about what I'm doing. Just use a chain rule. Screw it. Okay. So the derivative is 1 on 4 pi times 2x plus 1 on 16. Now, so bring the 2 down, leave the middle, times by the derivative of the middle, which is minus 1, and I simplify. Okay, so that's 1 on, so that's going to be 2 on 4, which is 1 on 2, so that and that make 2, pi x plus 2 on 16 is 1 on 8, so that becomes 8. 100 minus x, and then times by minus 1, so I'll turn that into a minus. Okay, and I want to show that it's a minimum, so in other words stationary at point, to set that equal to 0. Let's expand that thing. 1/2 x minus, what's 100 on 8? Is it 12.5? Yeah, 12.5 plus 1 on 8x equals 0. Let's move the 12.5 over and I'll factorize the x out. So x outside of 1/2 pi plus 1 on 8 equals 12.5. X equals 12.5 on 1/2 pi plus 1 on 8. Which equals, I want it in terms of pi. Damn it. I'm not going to be able to. Do I want this exact? Is it going to ask me for it exact? Near a centimeter, oh thank God. Okay. 8.646. 3 decimal places. That's what x equals. What am I trying to find? What length should x be? Oh. Am I done? Okay, I need to show that it's a minimum. Second derivative. d2a on dx squared. What's my first derivative? That thing. So 1/2 pi, the x goes, minus 1 on 8. Actually, can I just use this expanded version? Let's use this part. Oh, plus 1 on 8. That's it. And that's positive, which is greater than 0. Therefore, it looks like this. Therefore, it's a minimum. There's my proof, and that's my x value. Is that right? Please, please, have mercy. Have mercy. No! Mistake! Mistake, mistake, mistake. My first derivative's wrong, I believe. I swear if that's a minus now. Damn it. Was that the same wrong? Let's see if I can quickly spot it. If not, I'll give up. That's my derivative. I brought front. It's minus, then I divide by it. Can't see a mistake anywhere. 2x. Can't see a mistake, but that's wrong. It's 44 supposedly, but the rest of it's right. Derivative x on. Oh, you idiot! It's this. The pi is down here, not up there. Okay, that's easy. That's in there. That means that's in there. Okay, that's fine, that's fine. This is salvageable. This is me not being able to solve a simple equation again. You get so fixated on all the calculus and stuff, and then you do the easy stuff wrong. Yep, and I got it right. After a second try. 44. This is the last question. Oh, how long have I taken? Oh, it's been an hour. Okay. That's right, I can beat this in 8 minutes. Here's an identity. That's a double angle formula. Cool. Use it to solve this. Oh, sick. Okay. Sine 2x. No, I don't care. It was cos x. Using this. 2 sine x cos x equals cos x. That means, let's bring the cos x over. So I was going to cancel then, but that'll get rid of a solution. I'm just going to minus cos x. So then factorize the cos x. Minus 1. If I went like this just then I would have only had this solution, but I also need this one. So that means either cos x is 0, or, so that means x is equal to, when is cos 0? Cos is 0 at 90 degrees, and it's between 0 and pi on 2, so it's at 90 degrees, good. And then 2 sine minus, so that's 2 sine x equals 1, which means sine x equals 1 on 2. It means x is equal to 30 degrees, which is pi on 6. And that's the only solution in there. Cool, done. Sketch the graphs of them, damn it. In these bounds, okay, so I need between 0 and, let's call that pi on 2. Okay, what does cos look like? We'll do that one first because it's not affected. This looks like, and that's 2 pi, which means that's pi, which means that's pi on 2. Okay, so that means maybe I've drawn this thing too large. Let's go here. 1 goes like that. Okay, that's cos. Sine 2x. Okay, so sine looks like that at 2 pi. 2x is going to be like that. That's pi. That's pi on 2. Okay, interesting. So it does like a loop. That's terrible, but you get the gist, I hope. draw this. Okay, they end up at the same points. There's no gap there. Alright, drawn. Am I done? No. Oh no. Hence find the exact area bounded by the graphs by finding the area of two separate. Yeah, okay. Alright, so I've got to find these areas. This area is going to be, let me just label stuff. That's sine 2x. So this is going to be, so to find the area between things, it's the integral of this, which will give me all of that, and I take away the integral of this, so this. So I'm going to do the integral of cos minus sine between, oh geez, where's that? Do I need to find that point? Surely that's in between. Do I have to? Oh, I solved it, didn't I? Oh, that's so lucky. Okay, that's why they did that at the start, because they cross at pi on 2, which is this. They also cross at pi on 6, which is this. So that's pi on 6 from A. Okay, so I'm looking for the integral from 0 to pi on 6 of the top one, which is cos, minus the bottom one. So cos minus sine 2x. Okay, dx. Take away the integral from pi on 6 to pi on 2, so the rest of it. But this time sine is on top and cos is on the bottom. So sine is on top, cos is on the bottom. Okay, am I done? Good. How long have I got? 3 minutes and 15 seconds. Okay. Alright. Cos x, integral is sine x. Negative sine, so cosine goes to negative sine, so it's plus 1/2 cos 2x between 0 and pi on 6 minus sine 2x. I just did that. It was, oh no, it's minus sine, so cosine goes to negative sine, so that means negative cos, no, negative 1/2. Oh my god, this thing's on 3%. 1/2 cos, I just realized that. Why am I stressing so much? This is minus sine x between pi on 6 and pi on 2. What's going to end first? The timer, my battery on both this and the pen, or let's stop talking. Okay, so sine pi on 6 plus 1 on 2 cos, so 2 pi on 6 is pi on 3 minus sine 0 plus 1/2 cos 0 minus, holy moly, okay, minus 1 on 2 cos 2 pi on 2 is just pi, far out, minus sine pi on 2, okay, and then that's minus, there's a lot of minuses here, eh? I'm going to need massive brackets. 1/2 cos, now 2 pi on 6 is the same as pi on 3 minus sine pi on 6. No way I get this right. Working out is atrocious. Please do this much slower than I do normally. So sine 30 is 1/2. Cos pi on 3 is also 1/2. I think. Cos pi on 3. Yep. Okay, minus sine 0 is 0. Cos 0 is 1, so that's plus 1/2. Minus, big bracket, minus 1/2 cos pi. Pi is here. Cos is the x value, so it's minus 1. Minus sine pi, so that's 1. Minus 1/2 cos pi on 3. That's 1/2. Sine pi on 6 is also 1/2. Alright, no way I get this right. If I get this right, I'm going to scream. That's 1/2 plus 1/4 minus 1/2 minus 1/2 minus 1 plus 1/4 so minus, that's plus 1/2. And that's in brackets. Jesus. Goodbye. 1/4 minus 1/2 plus 1 minus 1/4 minus 1/2. There you go. That's 1 plus 1 is 2. Surely this isn't 2. Surely the answer's not 2. No, it's a half. We're so close. No, that's not even right. That's minus. Minus, minus. That's telling me it's a 0. That's not right. Ah, look how close we are. Sure, I can find my mistake in... No, it's been an hour. Ah, well. You win some, you lose some, eh? Still trying to find my mistake. Well, mission failed. We'll get them next time. Trying to see if it's a real easy one. Minus 6. I don't think it's a really easy one. It's always bloody minuses in the way. Guess I could put that there. Oh well. I'm sure it's there. But that's the end of that exam. And I would have gotten 2 marks, hopefully. That's annoying me. Minus 1. No, screw it, we're gonna find it. Yeah, I can't be bothered.